Let's talk about cubing functions. Guess what this function does to your input values? It cubes it, so you get x to the third. So let's make our t-table of values and see what I have here. Here's x and y. Yes, go for the defaults. -2, -1, 0, 1, and 2. I plug in -2, what do I get?
8.
I cube that, I get -8. Plug in -1. Plug in 0, I get 1, and I get 8. You guys with me on that? Now let's plot these points. -2, -8's down here. -1, 1, 0, 0. Now, let me show you something about this. If you just did -1, 0, and 1, this is what you would have had. If only have is those three, if you only have those 3 points, that's not enough to tell you what's going on. Can you draw a line through that?
Mm-hmm.
Yes, you can also draw several other graphs that will go through those 3 points. But now that I have these points here, I know how I need to connect it. Now let me show you how you get the right shape for this. Around the origin it's kind of flat, and it looks kind of like a parabola, and it gets steep very, very quickly. It looks like this guy. Kind of half a parabola, but not exactly. The higher you go for the power, the flatter it gets around the origin and the steeper it gets on the outside. And I'm going to do the same thing down here. Kind of flat, and then he just gets steep very, very quickly. So there's your shape. Note your key points. You've got 2 and 8. Down here is -2, -8. A lot of times those guys are forgotten from the main 3 ones you have right there. What do you guys think about that? Is it awesome? Now, let me show you I'm going to change this guy up just a little bit here. I want to show you the way that the computer drew the graph for me. So here's the graph of the cubing function. That's what I have, right? Now I want you to watch this. I'm going to turn it upside down. I want you to see the difference. Did you guys see a difference here? No. What if I turned the parabola upside down? Would there have been a difference? Yeah, instead of holding water, it'd be dumping the water out. But this guy, he still has the same shape, right? He's still going through the origin, and all the other points seem to match up. This guy has symmetry. But it doesn't have symmetry about a line. It has symmetry about the origin. If you can twist things 180 degrees about the origin, and it still looks exactly the same, it's what we call origin symmetry.
Does it have a vertex?
It doesn't have a vertex. What you're going to find out with the cubing function, this point right here, notice if you kind of kept going here on this part, it looks like it's kind of opening down like this. But then this part kind of has this open up curve like that. Where it changes from being curving down to curving up, this is called a point of inflection. And that's something that you would find if you were to go on to take calculus. Calculus will tell you how you can find the slope at any point on a graph. And you can also find things called these points of inflection. Even if I had something that's based off of the cubing function that looks like this. Notice how you're curving down right here, opening down, then this guy's opening up. Your point of inflection would be that point right there, where you change your curvature. The calculus word we use is called concavity. Okay, it's called concavity. But notice for this whole function, though, you are increasing the whole way, right? This guy's always increasing. If you go back and look at the squaring function, was the squaring function always increasing? He was decreasing, and then he was increasing, right? So just kind of going back and talking a little bit more about this guy. This guy is decreasing on the interval from -infinity to 0, right?
Mm-hmm.
And then he's increasing on what?
0 to infinity.
Does that make sense? Okay. And what would you say? What do we say about this guy right here?
Always.
So this guy's increasing on the interval from negative infinity to infinity. This guy's increasing for all real numbers. Yeah. What about a constant function? What if I had just this line right here? Hope that should be completely flat. Is that guy increasing or decreasing?
Neither.
It's what?
Neither.
Neither. So you could say this guy's constant on the interval
Constant
from.
function. Well, it's a constant function.
Yeah, it's a constant function. It's a constant function.